I appreciate you stopping by to check out this episode of Vintage Audio Review. In 1982, if you were looking through your audio, stereo review, or other magazines geared towards men, you probably would have come across this ad from Pioneer. It touted their top-of-the-line SX-8 stereo receiver as well as their CT-9R cassette deck. This was rated at 100 watts per channel into 8 ohms from 20 Hz to 20 kilohertz at not more than 0.005% THD. It sold for $800 back then, which would be $2,500 or so in today's money. Now, this particular unit came to me broken. It had some really bad hum coming out of it, similar to what you would hear if there was a leaky capacitor in the power supply circuit, and there wasn't a lot of sound to begin with. So it did come to me broken. I will go into what I found that caused that problem and when we look in the inside of the unit, but I wanted to go over the features that this had. One of the things that Pioneer touted for the SX-8 was its lack of potentiometers. It had no potentiometers for the balance and the volume, and they were claiming that that created a more pure sound. I'm going to show you some of the features of it, and especially for the time, a lot of these features were, really state-of-the-art. And then we'll go around the back, and I'll take off the top, and you'll get to see the inside. And then eventually we'll get to the data. So now I'm going to give you a tour of the SX-8. You'll see right here we have a clock display, and I will point out that one of the segments for the one right here is missing. Sometimes it comes on, but for the most part it is not functioning correctly, but it doesn't really affect anything. Now the power button's here. If I go ahead and press that on, this thing flashes, and then you'll hear a relay click if everything's okay. Hopefully you heard the relay click and this stopped flashing. We do have a 1/4-inch headphone jack here, and we have our speaker selector here, so we can have A, B, or A and B, or just B, however you want to do it. This right here is our clock. If we hold that down for a second, we go to the clock mode, and then if we want to change the clock, we use the tuning up and down arrows. Our tone controls are here, and it has some unique features in that you can increase the bass, and you'll see the bass right here go up. It has a maximum of 7, and if we want to get back down to 0 quickly, we can hold the flat down. If we want to decrease the bass, you can see it's a different indicator there for the minus, and now we're at -7, and we can get to flat real quickly. And likewise, we have the same for the treble. That display is at 7 right now. If I hold it down, 0. If I want to decrease the treble, it's indicating minus, and there's -7. Now it also has presets, so you have 2-tone presets, and what I could do is I could increase, say, the bass up by a bit and the treble up by a bit, and then if I hold the memory button, so here's a memory button right here, if I go ahead and hold that down, things flash, and if I press A, you'll see right here it put it in tone A. And there's also a tone B, so we'll just go ahead and get to a different setting. So if I want that to be in B, once again I hold the memory button down, things start flashing, and then I hit B, and you'll see the little preset for B came on. So I would have 2 different tone presets now, so if I press the A, it's on the A, and there's the B. So that's kind of just a little bit different. Now these FM stations up here, we have a total of 8 either AM or FM presets. You can have 8 AM presets and 8 FM presets, and there is a little slide out thing right here. You can see I pull it out, and I guess they had different numbers that came with the unit when it was new that you could put in there for the channels, but those are just going to be, FM 1, 2, 3, 4, whatever. We do have our power meter is here, and you will see how accurate that is in the data. What we also have on this front display we do have some controls. Here's our mono and our mute. switch for the FM tuner. We also have some different scan modes. If we go to auto, it's going to, if the auto is selected and we hit the tuning up, it'll stop at the next strong signal. You can see that it's a stereo signal here, and we also have the signal level. There's 3 LEDs that light up depending on how strong a signal it is. Now if I wanted to manually tune a station, I can push this switch in, and then if I go up, it just goes by small increments then. And we'll go back out to auto, and then we have a couple different methods of scanning when it's in auto mode. There's station search and station scan. So the way the station scan works is if I now hit my tuner up, it's going to scan across all the stations, and when it finds a tunable station that's not in memory, it's going to let you know that. So right now it's on station scan, and it's flashing 3 LEDs above 1, 2, and 3, and that means that those are open. So if I go ahead and hold that down, I don't know how well it's going to show up, but it was at 107.5 when I pressed the 1 and held it. So that should now be in 1. So if I go ahead and press 1, we are at 107.5. So that's kind of how that feature works. Here are our input selectors. We have FM, AM, phono, auxiliary video, tape 1 and tape 2. Here are our tuning up and down arrows. This is our balance control, and if you look at these 2 little balance indicators here, right now they're both on, so they're balanced. If I go ahead and click on the left a few times, you'll see the right disappears, which means that our left is more of the balance is towards the left channel than the right channel. And if I go ahead and continue to press the right down a few times, now we got the right back balanced with the left, and now the right channel is on. Now we have more balance towards the right when we have no indicator for the left channel. I'll go ahead and bring it back, so now they're balanced. Here is our loudness on-off switch, and when you have it on, you will see that there's an indicator right here that goes on and off depending if the loudness is on or off. We also have a muting switch, which is up here. This is our muting, and the light over here comes on that tells you the muting is on. We also have our selector for either moving coil or moving magnet for the phono input right here, and we have a 15 Hertz subsonic filter here. We also have presets for the volume, which are right here, so we can have, if we go ahead and turn the volume up, and then we press the memory, and then we hit A, it's going to be at 9, and let's just move the volume up to something else, and we go ahead and it's at 13, and I press A, and I moved it back to 9. So we actually have 2 volume presets for, I guess, different uses, I suppose. Anyway, that's kind of a tour of the unit. I think I've covered most of the functions on it. Now, I will point out, when I got this unit, the muting and loudness could not be switched on or off for whatever reason, so that was part of the problem with the connectors, which you'll see a little later on when we get the cover off. Coming around back of the SX-8, starting on the right, we have our speaker connection points here. They're the kind where you push down and then insert your wire. Here are our unswitched AC outlets, and we have 1 switched AC outlet. This guy right here is our channel step size for the AM/FM tuner. It's usually set for 10 kilohertz for here in the United States. Right here are our pre-out main in jacks, and we do have jumpers in them. Here is our AM antenna rod. Here is an external AM antenna connection, as well as over here is our FM connection. So right here is a connection for the AM stereo out. I'm not really sure exactly how that's used, but apparently at some point they were thinking that AM stereo may be possible. Here are our tape monitor loops. There are 2 of them. Here is our phono input here. And here is our auxiliary video input, and here is a grounding connection for the phonograph. So this circuit board is on the right side of the SX-8 if you're looking at the front of the SX-8. And the problem that I found turned out to be that this connector here, there's one underneath here and another here, just needed to be reseated apparently. And in order to do that is you loosen these two tabs, there's one here, and then you can pop the cable out, make sure that the wires on the end don't have any corrosion, and then just put them in nice and tightly and push those two ends down. And I did that and the problem went away, which was nice because this thing would be a real booger to work on for most things. But that's where the problem was. I didn't see any problem on any of the other boards, but we're going to go ahead and kind of take a look at what's going on in the SX-8. So I turned the SX-8 on the side so we could look at some of the innards of it. The board I just pointed out is this guy right here. Here are the two power supply caps, and they are 63 volt, 12,000 microfarad capacitors. Here are our heat sinks for the output stage, and the circuit board that has some tuner functions as well as some of the display control functions is here. So this board right here has 3 adjustments for each channel, and you can kind of see at least one of the, or two of the controls there, and that would be our power amplifier driver board. So that's a continued view of that, showing the pretty big power supply transformer, and there are several fuses here. The front of the SX-8 is right here, and here is a bottom view of the SX-8. The front of the SX-8, the front panel of the SX-8 would be on this end, and you can kind of just see just a little bit more as to what's going on. Here we have the THD SNR plot at 1 kilohertz with the SX-8 putting out, well, we'll say 5.3 watts for the left channel and 5.8 watts for the right channel into 8 ohm loads. The THDs are less than 0.03%. The SNRs are right around 6970 dB, and the THD plus noise is around minus 68, minus 69 dB. The gain is set for about 26 dB or so. The way that the volume control works on this thing, it's digital, and if I press it once, I'm going to get a gain of about 30 dB, and then this power jumps in the 6 watts, or if I go down, it'll jump down in the 2 watts. It's got a very coarse resolution, at least in my opinion, as far as a digital volume control. Also, I should note that the balance is set so that the control, which is digital, is in the middle as indicated by the LEDs that are on, and so this is really as balanced as I could get and as close to 5 watts as I could get. Right now we're looking at the frequency response from 10 Hertz to 40 kilohertz of the SX-8, putting out 5 watts into 8 ohms. The channels are fairly well balanced, I would say within half a dB of each other. The frequency response is down only at 20 kilohertz, which would be right here. It's down maybe 0.3 of a dB. That's really good. And at 40 kilohertz, it's down maybe 1.2 dB or so. And at the low end of the band at 10 Hertz, we're down maybe 0.6 of a dB. And at 20 Hertz, we're only down 0.1 of a dB or so. Here we have the THD SNR plot at 1 kilohertz with the SX-8 putting out around 50 watts into 8 ohms for the left channel and 54 watts into 8 ohms for the right channel. The reason for that is there is a specification that at 50 watts output, the THD should not be more than 0.005%. We're at 0.08% on the left and 0.05% on the right. I would say that's still pretty darn good, even if it's not the 0.005% THD. Also, the SNRs aren't bad, right around 78 dB,
and the THD plus noise is still between minus 62 to minus 67 dB. So overall, it is looking pretty decent for this 41-year-old amplifier. Here we have the THD SNR plot at 1 kilohertz with the SX-8 putting out, we'll say 98 watts for the left channel and 106 watts for the right channel into 8 ohms. The specification for the SX-8 is 100 watts per channel into 8 ohms at not more than 0.005% THD. We're less than 0.1% THD, which I think is really pretty good. And our SNRs are looking about 80 dB. That's not bad at all. And the THD plus noise really hasn't changed much, and it's minus 60 to minus 64 dB. Now, if I turn on the harmonics, so I brought up the harmonics just to kind of look at them, and it looks like the second and third harmonics, the even and odd harmonics, are pretty much at the same level. So right now we're looking at the THD SNR plot at 1 kilohertz again, with it putting out about, we'll say 96 or 104 watts into 8 ohms. And what I wanted to do was crank up the power level and see how much we could actually hit at 1 kilohertz into 8 ohms. And so I'm bringing it up a little bit. So the right channel is definitely not looking as clean. You can start seeing all those little harmonics going in and out. A little bit more power. And the right channel now is at almost 1% THD. The left channel's we'll call it 0.2%. That's not bad. The SNR on the right channel is about 30 dB less than the left channel right now. So I'm going to say this thing is still good for 100 watts. You don't really want to get a lot over probably 105 for the right channel. Let me just bring that down. So at 105, we're looking pretty good on the right channel, and we're 97 on the left. So that's kind of the story on the amplifier as far as the maximum output power. This plot shows the output impedance of the SX-8, and if you look at what this translates to as far as damping factor, it is between 20 to 35. The specification was 50. This plot shows the THD versus frequency at a couple different power levels, and that's into 8 ohms, anywhere from 56 watts to 3.5 watts. And basically, the SX-8 has better than 0.1% THD over the band at the highest power level that I ran it at, which would be 56 watts. Here we have the multi-tone response of the SX-8, and it's showing anywhere between 10 to 13 bits of distortion-free range. This plot is showing the crosstalk or isolation between the left and right channels. In this case, a signal is applied to the left channel, and the right channel is terminated into a load, and you're looking at the amount of leakage of the left channel onto the right channel. We are seeing better than 50 dB of isolation or crosstalk between the two channels. There is no specification for this that I could find, but 50 dB is not too bad. So right now we're showing about 31.5 watts for the left channel and 35 watts for the right channel, and that's into 8 ohms, and our power meter on the SX-8 is reading 150 watts. Now I'm going to decrease the power level until the next marker is hit, which would be 100 watts, I believe. That would be the mark between 150 and 10. So at approximately 20 watts for the left channel and 22 watts for the right channel into 8 ohms, we are reading 100 watts on the SX-8's power meter. Our next stop is going to be 10 watts. Okay, we are there. So for 10 watts on the power meter, we're around 6 to 7 watts actual power into 8 ohms. The next stop would be 1 watt. So right here we're at about 1 watt and our power meter is reading 1 watt. And we're going to go down one more notch until we're at 100 milliwatts. So at 106 milliwatts for the left channel and 119 milliwatts for the right channel into 8 ohms, the SX-8 power meter is indeed reading 100 milliwatts. Here we have the THD SNR response at 1 kilohertz with the SX-8's auxiliary input being used, and I'm applying about 150 millivolts to that auxiliary input, and I adjusted the volume control such that I got about 1 volt out. And to do that, I have between 15 and 16 dB of gain. That's just kind of where the specification was for the preamp measurement. And you can see that the distortion is less than the 0.005% pretty much at that point. Now I'm going to start bringing up the amplitude of that signal, this guy right here, and we'll see where it starts getting really bad looking. So as I start getting around minus 5.5 dBVN, the distortion is still not too bad. I'm going to go up just a little bit more. And right there at minus 5 dBV, you can see the right channel in particular now is at 1% THD, or pretty close to it. And that would be the biggest signal that I could apply to the auxiliary input of the SX-8 with it set for about 15 or 16 dB of gain. And we have about 3.5 volts that we're putting out of the preamp. So if for some reason you wanted to use this as just a preamp, you wouldn't be able to put more than about minus 5 dBV, which would be about 560 millivolts or so. So you wouldn't want to put any larger signal than that into the input. And if I lower the gain a little bit, it will also drop it down. So if I drop down the gain, I could put in more signal, so you could kind of play a little balancing act there. Here we have the frequency response of the SX-8 with the signal going into the auxiliary output, and we're measuring at the preamp output. The volume control is set to give us 0 dB gain with a 150 millivolt signal going in and about a 1 volt signal coming out of the preamplifier. The channels are balanced to within about a dB pretty much. The low frequency response at 10 hertz is down maybe half a dB, and at 40 kilohertz, which would be right here, it would be down about a dB. If you went from 20 to 20, we're down maybe 0.2 of a dB at 20 hertz, and at 20 kilohertz we are down maybe 0.4 of a dB. So overall, it's not too bad of a frequency response. This plot shows the effect of the tone controls as well as the muting, loudness, and subsonic filter. We'll take the muting first. That should be 25 dB according to the spec, and we're at about 29 dB. The subsonic filter, which would be this guy, is said to provide 6 dB an octave from 15 hertz. So that's probably in this range here, and we should be down about 6 dB. So we are pretty close to that. The treble and bass controls are supposed to provide plus or minus 10 dB. Now the 0 would be our flat reference line. That's with all the tones set flat. And so for the treble, we have a boost of about 11 dB maybe at 10 kilohertz. And we also have a boost of bass, which would be this guy, of about 11 dB over here at 100 hertz. So that's pretty close to what the spec says. And likewise, our loudness contour is this red line, and you can see it provides a little boost here, and kind of like the little smiley face comes down, and then we have a little boost here of treble. Not very much at all. The moving magnet phono input to the tape monitor 1 output, and the first thing of note is that we're getting about 36 dB of gain through the phono stage. Our THD is looking really, really good, less than 0.007% and 0.005%. 58 dB of SNR or so, and other than this 60 hertz hum right here from the power supply, and you have another one here at 180 hertz, the overall response is looking pretty good for a pretty old phono stage. Here we have the frequency response from 20 hertz to 20 kilohertz of the moving magnet phono input, and it is basically maybe within plus, I don't know, 0.3 of a dB here at the low end of the band, and down about 0.7 of a dB at the high end of the band. The channels are pretty well balanced between, I would say 0.3 of a dB or so. This little noise right here is a 60 hertz power supply hum that comes and goes. That's quite normal. But overall, the frequency response looks pretty good through the moving magnet phono section. This ugly plot is the moving magnet frequency response from 10 hertz to 40 kilohertz, and it is being measured at the preamplifier output. Earlier you had seen the frequency response of the moving magnet phono stage as measured at the tape monitor output, and the difference is that the tape monitor output comes right after the phono gain stage, and then it goes through some switches and the tone controls and such out to the preamplifier output. So there's something going on in one of the electronic switches, I would imagine, that is causing this problem. For grins, here is the frequency response of the moving coil phono input, and when you start looking at something with that small a signal and that much gain, you get a lot of magnification of the 60 hertz hum and 180 hertz hum. So that's kind of what this noise is. But overall, it doesn't look all that bad as far as the response is plus or minus maybe plus 0.2 of a dB and minus maybe 1.4 dB, and the channels are balanced within only about a dB. So it's not something I would probably want to use on this old receiver. For my listening test of the SX-8, I connected it to my Wilson Watt 3 Puppy 2 loudspeakers, and I used my little Surfans F20 music player for the source. I thought it did a great job playing the music that I normally did. It didn't add or subtract to the listening experience. If anything, I'd say that it's a pretty neutral sounding amplifier. I do like listening with the loudness on more than the loudness off, and I even boosted up the bass a little bit when the loudness was off, just because I wanted a little bit more bass. And I just thought it did a good job. There were no weird sounds turning it on or off, no weird pops or thumps. When I shorted out the auxiliary 1 inputs, I heard very little hum or hiss coming out of the Wilsons. There's a little bit, but you couldn't hear it once you were a few feet away, but it was pretty normal for most of the amplifiers, and it wasn't detraction to listening to them. It does get a bit warm. The top of it gets, I mean, you can still put your hand on it, but if you play it loud for a while, it does get warm. You wouldn't want to put a candle on the top, that's for sure. What other little things? As you saw in the data, this thing does pretty well up to about 100 watts. It's really not going to give you a lot more than 100 watts into 8 ohms with this unit. Maybe some little peaks it can go over 100, but for the most part, it's about 100 watt per channel into 8 ohms at a reasonable amount of distortion. As you saw from the data, the phono frequency response was really crappy looking, and there's a reason for that. Once I had finished listening to it, I hooked it up onto my other bench, and I wanted to just play with the tuner so I could understand how it worked for this video. And I'm listening to the tuner, and it's working really good. And then I had my little F20 source hooked up to the aux 1, and I selected the auxiliary 1, and I'm listening to the music from the little music player, and I'm also hearing FM radio coming out. So Apparently there's a bleed through from either the AM or FM onto the auxiliary input or the phono input, whatever is selected. I did some further troubleshooting, and I'll show you the part of the schematic that I did check. There is an electronic switch. There's actually two of them. They are Pioneer 4008 is the part number of the IC, and I injected an FM signal at I think 88.5 megahertz with a 1 kilohertz wideband modulation on it, so I could hear a tone coming out and monitor it with the scope. And what I found is that there is that tone gets out to the either the auxiliary or the phono outputs on that chip. I think I'll show a little schematic here so you can kind of see what it looks like. Based on the voltages going in to that IC, I decided it was worth swapping that IC. The owner of this had a couple different SX-8s, so they have two ICs in there. And I pulled an IC out and put it in, and I had the same problem. So at this point, there could be something with the, there's some diodes and transistors that toggle the selection inputs, and I'm guessing one of those are bad or leaky, but it's hard to work on for the amount of time that I spend doing these things, so it's gonna not get fixed to be perfect. So you could use this. You could just listen to either AM or FM, and you could also listen to an auxiliary or your phono, but you would want to have your FM tuned to where there was no station, and say manual tuning, set it to a station with where there is no signal, and have the muting on, and that way you won't get any bleed through. So it could work. You'd have to just adjust the FM station to where there is no signal, basically, and then you could use it. But I have limited time to do certain kind of repairs, and this is not a fun unit to work on. As far as the sound, in some of the features, it's kind of cool. You would think that they may have had a remote for a unit like this, but it did not have remote capability, unless you add an external remote for the volume, as you saw in an earlier video. But that being said, if you were to pick one of these up where you can check the features and the functions and see if they work, and you can pick it up for a reasonable price, I would say not more than $200 would be my guess. You know, and use it, and if it breaks, oh well. But they're kind of a cool unit, I think, with what they do, and a lot of people and possibly people will start collecting these because they are less expensive, but the parts on some of the specific computer kind of related ICs are going to be very difficult to find unless you have parts units. They're just kind of neat. If you have the cassette deck, I do have the CT9R cassette deck, which at some point I'll do a review on, or any of the other pieces that are in that line. Those would be kind of cool to have just on your rack, I suppose. But you want to be careful with these because apparently they do have problems. I do have two other units that the relay doesn't click on, the outputs aren't shorted. I'll spend a little bit of time, but it's not the easiest receiver to work on as far as getting at the boards and access points for troubleshooting. And I like to work on things, but after a while I just have many other things to test or maybe do minor repairs on. So this one's gonna just stay unsolved, I guess. That being said, I thank you for taking the time out of your day to watch this video. If you have not subscribed to the channel, it would be nice if you did so. And if you like the video, click the little like button, or thumb, I guess it is. And if you have any comments, I would love to hear from you. Once again, until next time, have a great day or night.